Picture this, you just paid your Snowflake bill and it doubled overnight. Nobody added data, nobody added users. And yet the number climbed. Here is the secret. There is one idea that explains your whole platform. It explains warehouses, caching, cloning, sharing, and that very bill, storage and compute are separate. Get this one thing and Snowflake stops feeling like magic. It starts feeling like a machine you control. Let me show you exactly what that separation buys you. Think of two boxes, not one. The first box is storage. There is one single copy of your data sitting in cloud object storage. Always there, it does not turn off. The second box is compute. Those are virtual warehouses you switch on to do work, then switch off again. Here's the mental model I want you to keep. The engine and the fuel tank are separate things. You can change one without ever touching the other. That single split is the whole lesson. To feel why this matters, look at the old world. Traditional warehouses glued storage and compute onto the same machines. They were welded together. So you needed more query power. Fine, but now you also paid for more storage you did not need. And the reverse was just as painful. Scaling up meant downtime, shuffling data across nodes, and a bigger bill for both halves. You could never tune one without dragging the other along. Snowflake was built to break that chain. So how does Snowflake actually split it? Take a look at three layers. At the bottom sits the storage layer. It holds your data as compressed micropartitions, completely independent of any engine. Above it sits the compute layer. These are virtual warehouses, clusters that spin up, read from storage, do the work and spin down. On top is a thin services layer that coordinates everything. But here is the key. Data never lives inside a warehouse. The warehouse just borrows it, reads it and lets it go. Now watch what that unlocks. Your BI team, your ETL team, and your data science team each get their own warehouse, three separate engines, and all three read the exact same single copy of data. No copies, no nightly syncing, no stale duplicates drifting apart, and because each team has its own compute, they never fight for resources. The heavy ETL load at 2 in the morning cannot slow down the analyst running a dashboard. That is isolated compute on shared data, and it is the dream. So the obvious question, how many warehouses should you actually create? The upside is clear, isolate by workload, and one heavy job can never starve another, but there is a real cost to going overboard. Every warehouse is a separate meter. Spin up too many and the idle ones quietly waste credits all day. So here is the rule I give every team, one warehouse per workload pattern, size to fit that pattern and always auto suspended. Not one giant box, not 50 tiny ones. There are two ways to grow a warehouse and people confuse them constantly. The first is to scale up. A bigger warehouse size gives one heavy query, more horsepower, so it finishes faster. The second is to scale out. Multi-cluster adds parallel clusters, so many users do not sit in a queue. Here is the line that keeps it straight. Size is the speed of one query. Clusters are how many can run at once. They are two completely different dials. Pick the dial that matches your actual problem. Let me show you the commands because they are wonderfully simple. You create a warehouse, give it a size of small, set a minimum cluster count of 1 and a maximum of 3. Auto suspend after 60 seconds and auto resume on that one statement is a fully managed cost aware engine. Now here is the part that still amazes me. You can resize it live with zero downtime using a single alter warehouse statement to bump it to medium. No maintenance window. The resize simply takes effect on the next query and no data moves at all. This is elasticity and it is the payoff of separation. Picture a month end crunch. Your reports are crawling. So you size up to large for 1 hour, then size right back down. And because the data lives in shared storage, that resize moves no data whatsoever. It just swaps the engine underneath. Bigger engine, same fuel tank. Think about what that really means for you. You scale the bill to the work, not to the data. You pay for the busy hour, not the quiet ones. Now let us put the whole cost model in one picture. You pay for warehouse running time and credits, plus storage, which is relatively cheap. And here is the beautiful part. A suspended warehouse bills zero compute. Nothing. Storage is just a small constant baseline ticking along underneath. So your Snowflake cost is mostly a function of how long your engines run. And that number is entirely in your hands. Compute is the variable you control. Master that and you master the bill. Now, this same separation explains the real gotcha, so pay attention here. Each warehouse keeps a local SSD cache of the micro partitions. It recently read that cache makes repeat queries fast, but the cache is tied to the compute, not the storage. So the moment you suspend or resize that warehouse, the local cache goes cold. The data is safe in storage, of course, but the speed boost is gone. So a freshly resumed warehouse means a slower first query while it warms back up. That one detail explains a lot of mystery slowdowns. Which brings us to a genuine production trade-off. Should a warehouse stay always on or auto suspend? Always on means a warm cache and instant dashboards, but it builds around the clock even at 3 in the morning. Auto suspend means near zero idle cost. But the first query after a quiet spell pays that cold start tax. So here is the rule. A latency critical dashboard, the one an executive opens every morning, may justify a small always on warehouse. Everything else auto suspends, warm where it matters, off everywhere else. Let me show you the most common mistake I see. One giant warehouse running everything, ETL, BI, and ad hoc queries all crammed onto a single large engine. It feels simple. It is a trap. Here is why. It breaks. The workload's content so one heavy load stalls the dashboards. And because something is always running, it never idles down. So you get the worst of both worlds. It is slower than isolated warehouses, and it is more expensive too. Simple to set up, painful to live with. Here is the second classic anti-pattern. Oversizing to be safe, someone jumps straight to a large warehouse and disables auto suspend. So nothing ever has to wait, it sounds responsible, it is just expensive. Most of that capacity sits idle, billing every single minute. You are paying for a sports car to sit in the driveway. The right move is the opposite. Start small, measure your queue time against your runtime, and size up only when the data actually tells you to. Let measurement decide, not fear. So here is the pattern that gets it right. Workload, isolated warehouses, each one right sized for its job, each one auto suspended. Then use multi-cluster only where concurrency is genuinely real, like a shared BI warehouse that dozens of analysts hit at once. Not everywhere, just where the crowd is, and all of these warehouses read one shared copy of data. That last point is the whole reason any of this works. Separate engines, one source of truth. So how do you find out where the credits are actually going? Take a look at this query. You select the warehouse name and the sum of credits used from the account usage warehouse metering history. Then group and order by the biggest spender. In one shot that tells you which warehouse is eating your budget. And that is exactly where you start tuning. Chase the biggest number first, then pair this with resource monitors. So a runaway warehouse can never quietly surprise you on the bill. See the spend, then govern it. Now let me give you the actual ops recipe for right sizing. Open the query profile and watch two numbers, time spent queuing versus time spent running. These two numbers tell you everything. Lots of queuing means users are waiting in line, so scale out and add clusters. Slow single runs means the engine is underpowered, so scale up to a bigger size. And if a warehouse sits idle most of the day, size it down and shorten the auto suspend. The discipline is always the same. Measure first, then adjust. Let me make this concrete with a real team layout. Take a look at three warehouses. The BI warehouse is small, multi-cluster 1 to 3. Auto suspend 60 seconds because you have many analysts hitting it in bursts. The ETL warehouse is medium. Single cluster auto suspend 60 seconds for scheduled heavy loads. And the ad hoc warehouse is extra small. Auto suspend 30 seconds, a cheap sandbox for exploration. Three engines, one copy of data, each tuned to its job. This is a layout you could ship Monday morning. Now, here is the payoff that ties the whole platform together. Almost every Snowflake feature you'll ever learn falls out of this one idea. Time travel and zero copy clone. Those work because storage versions your data independently of compute. Secure data sharing that works because someone else's compute reads your storage directly with no copies. Per team concurrency and elastic cost. That is just separate compute on shared storage. One principle and the whole feature set unfolds from it. Let me hand you the decision card to keep need more power for one query. Size up, need to serve more concurrent users. Scale out with clusters. Is the workload latency critical? Consider always on. Everything else auto suspends and the backbone rule under all of it. One warehouse per workload, right sized, all reading, shared data. Then watch it with the warehouse metering history. Screenshot this card. It answers most warehouse questions you will ever face. So let us pull it together. We started with one idea, storage and computer separate, and we watched the entire platform unfold from it. Isolated warehouses, live resizing, the cost model, caching, time travel, data sharing, all of it. This one lens shapes every Snowflake decision you will ever make. If you want to go deeper, the full Snowflake Masterclass Architects, a real account on top of this idea, and the link is below. Subscribe for the cost and pipeline deep dives coming next. And I'm curious, what does your warehouse layout look like? Drop it in the comments.